For the question, you can refer Leetcode. I'll attach the problem link in the description section. Uh, Overall, the problem is that you are given an array and you are given as k value. Now, k denotes the size of the window, and you have to find out the maximum element in every window of size k. For example, if you see here, I have written some example here for the given array. For the first k elements, the maximum element is 3. For the next k element, the maximum element is again 3. For the next k element, the maximum element is 5. For the next k element, the maximum element is 6. And for last, it's 7. So, how to solve this problem? So, let's discuss the algorithm here. So, to solve this problem, you need dq, and you need to maintain the decreasing order dq. Okay, so it should be a decreasing order dq, and in the decreasing order dq you have to take care of three things. Okay, now let's discuss the three things. The first thing is maintaining a decreasing order dq. The second thing is maintaining k window size of dq, which is very much important. The third is pick the first element from the dq. Now let's see a dry run, and all these 3 points will be very much clear to you. So we begin from the first index, which is 1. So while writing the code, we will use index in the DQ, but for understanding purpose, I am using the values here. So we see that DQ is empty, so we'll insert 1. Okay. Now we move on to the next spot, which is 3. Now 3 is greater than 1. Okay, so we'll pop out 1 and insert 3, because remember we are maintaining a decreasing order, right? All right. So next is -1. Now -1 is lesser than 3, so we can insert -1. Now at this point, while we have already taken care of one window of size k, right? And what is the maximum element in this window? Well, the first element of the dq, which is 3. So we can insert 3 in the first spot. So in the first window of size k, our maximum element is the first element in the dq. So remember, the third point, pick the first element from the dq. So that is this exact thing. All right, now let's move on. Now we go to -3 here. Now -3 is lesser than -1. Yes. So we can write -3 here. But one more thing is that we have already covered k size, and we are at the third index. That is, we have already scanned 4 elements. So we also need to take care that the elements which are out of the boundary of the k, they are no more present in the dq, which I have already mentioned in the second point, maintain k window size. So we have to delete 3, because it is out of the window size, right? It is out of the window size. Sorry, not no, it is not out of the window size. It is in the current window only. I'm sorry. Okay. Now again we have already covered k size, and what is the maximum window? What is the maximum element in this k size window? It is the first element of dq, which is 3. So we'll again write 3 in the second spot. All right. Now let's move on. Let's move on to the next element, which is 5. Now is 5 is greater, and one more before moving on to 5. Remember 3 is already got out of the boundary of the k, so we have to remove 3 from our DQ. Now, when we are scanning for 5, and since we are maintaining a decreasing order, we need to pop out both the elements, and we have to enter 5 here. The reason for maintaining a decreasing order queue is that so that if any element which is greater than the last elements in the DQ is encountered, then we know that in the subarray these elements which are lesser than our new element are no longer of any use. Okay, that is why we are maintaining a decreasing order DQ. All right, now that we have covered 5, we get what is the next maximum. It is 5 because 5 is there only in the DQ. Okay, now let's move on to the next element, which is 3. We can enter 3. What is the maximum element? It is the first element of the DQ, which is 5 again. That is in the -353. The maximum is 5. Okay, now that we are in 6, we see that we are uh, we are again getting an element which is greater than 3 and 5. So we'll remove 3, we'll remove 5, and we'll enter 6. Now what is the maximum element? It is 6. Now move on to the next element, which is 7. Now 7 is greater, so we have to remove 6 and enter 7 here. And what is the maximum element? It is 7. So we get our answer in this, right? So that is the overall algorithm, that is the overall dry run of this approach. So three things need to be remembered while solving this problem. First is maintaining a decreasing order DQ. The moment you get any element which is greater than the last element, you need to pop out those elements from the DQ and enter that new element to maintain the decreasing order. And why we are maintaining the decreasing order? Because we are interested in maximum element, right? So there is no longer any use of the minimum elements, so we can pop out those elements from the DQ. That is why we're maintaining a decreasing order. And one more thing to take care in this algorithm is to maintain the k-sized window. As you see in the code, I'll show the code. So in that code, the DQ contains the index so that we can keep a track of the window size. Okay, so keeping a track of the window size is very much important. So the overall algorithm, there are three main points. First is maintaining a decreasing order DQ. Second is maintaining k window size, and third thing is picking the first element from the DQ. So let's take a look at the overall code. As you can see here, we have our answer, which is of size n minus k plus 1, because it contains n minus k plus 1 elements. We are taking a DQ. So there is two checks. The first check is remove the number out of the range k, as I have mentioned here, which is the second point. So you have to pop all those elements which are out of the boundary of q. Okay, and the second check is here. You need to pop out those elements which are lesser than the new element for maintaining the decreasing order. Okay, that is taken care into this portion. And after these two, you have to add that new element, I mean the index. And if you are at an index which is greater than or equals to k minus 1, that is you have already covered k elements. In that situation, you can always pick the first element from the DQ, which is going to be the answer of your maximum element in the current sliding window, in the current window. Okay, so you can look at this code.